Okay, hi. So welcome back to the YEA Friday Big Talk. So YEA has been giving out a Friday Big Talks for 1.5 years on various topics in math, computer science, and physics. And so there are some changes that have been made since last semester. So the main change is now that the subject and difficulty of each lecture has been locked, or basically it's been determined beforehand. So And that is the main change. And you can see it down here. I don't know if you can see my cursor, but yeah, it's in the bottom center of the currently shared slide. So the second change is that each lecture has now been limited to 30 minutes with 2 lectures a week. And at the end of each lecture, the speaker will leave a question behind for the viewers as homework. And solution videos, of course, will be uploaded to a Discord server that we have and the YA YouTube channel within a week after the lecture. And so if you're interested, you can join the Discord server, and here's the invite link. Okay. I think you can all access the chat at least. Yeah. And so as you can see from the flyer, this hold on a second. So as you can see from this flyer, this month our math subject is going to be all geometry. So today is so today we'll have 2 lectures, and the first lecture is me, and it's going to be at an AMC level. Okay. It's going to be at an AMC level, and the second lecture is going to be at an advanced AMC level by Ethan Hanna. And then the conclusion will be done by Neil Yen. And okay, if you're gonna use a Discord invite, please use the second one that I just sent. So yeah, the first invite is one that has that is one that's going to expire soon. And so I'm going to make these co-hosts. Yeah. Okay. Yeah. So without further ado, I'll start. So yeah. So this is okay. So this is the first Friday Big Talk of the semester, and so I'll be doing it. And me is referring to Aaron Chen, of course. So yeah. Without further ado, let's get started. So my lecture is going to be on some special triangles, and so the first, it's mostly about theorems in triangles, basically. So the first is going to be on the median theorem, and the converse, and then the second one is going to be the second set is going to be the 30, 60, 90 theorem as well as its converse. And then after that is a 15, 75, 90 theorem. And then it's just a problem relating all of these. Okay. So yeah, let's get started. So the median theorem. So in any right triangle, the median to the hypotenuse is equal to half the hypotenuse. So I will share a new screen and share a solution. Okay. Do you all see the OneNote screen right now? I'll wait for responses. Okay. So at least one person can see it, which means all of you should be able to. So the median theorem, sorry. So it's basically in any right triangle. So, and a prerequisite is I hope you understand what the terms right triangle, medium, and hypotenuse are. If you don't, okay, so a right triangle is a triangle with a 90-degree angle, and so the medium, so a right triangle has two legs, and the hypotenuse is the side of the right triangle with that is opposite to the 90-degree angle, which also happens to be the longest side. And the medium is just the line from the opposite vertex to the set midline of any of the segments. So this is the medium in question, but this could also be a medium and so on. So what we want to do here is show that these three are of equal length. So a way you can do this is pretty simple if you understand how circles work. So you can just, so any 3 points can define a circle. That's a bit sloppy. So any 3 points can define a circle. So there exists a circle that has exactly one circle that passes through these 3 points. And so if you know something about interior angles of circles, you'll know that the measure of this angle, or so more accurately, in any circle that measures like this angle, A, if this angle measures A, then this measures A corresponds to 2A degrees of the 360 degrees of the circle. So this angle is 90 degrees, which means that this represents 180 degrees. And so that's exactly half of a circle, half of the 360 degrees of a circle, which means that this is a diameter of the circle. And so obviously the center, which happens to be this point, as defined by what a medium is. So, and so this point is the center of the circle in general. And so that just means that these three are all radii, and so their lengths are all equal. And so this segment is the median. So the median is equal to any of these two. And since these two are equal and they add up to the length of the hypotenuse, each of these is half the length of the hypotenuse. I'll just write h over 2. And so that means that this is also equal to h over 2. And so that proves that the medium to the hypotenuse is exactly equal to half the hypotenuse. So are there any questions regarding this problem or this proof? Okay. So now on to the converse. So here, yeah. So this is the converse of the median theorem. So we want to show that if the median to a side is equal to half of that side, then the triangle is right. Okay. So now I will reshare the OneNote. Can I assume that all of you can see my OneNote? Okay, yeah, you should be able to. I will take no response as a good response. So now we have an arbitrary triangle. An arbitrary triangle. It's purposely not drawn right. And so the medium is exactly equal to half the length. And so that just means that this situation occurs. And the reason this occurs is because, well, the median obviously divides this side in half. So these two are equal. And we're given that this is equal to half the length of this, which means that these two are equal. And so, yeah, that's how these two are all equal. And so now these are isosceles triangles. And I have a bunch of isosceles triangles, or two of them, in fact. And that's basically enough. So a basic property of isosceles triangles is you can show that two triangles are isosceles by showing that these two sides are equal, or by showing that these two angles are equal. But either way, one of these conditions implies the other. So basically, as long as these two sides are equal, these two angles are equal, and vice versa. That's a rather basic property of isosceles triangles. So now you can just let this be A, and this be A, and so this will be A. And if you let this be B, then this will be B. And so that means that the sum of the angles of this triangle are A plus B plus B. And this is just 2 times A plus B. And so one of the basic conditions of triangles is that the sum of their angles is 180 degrees. So one of the ways you could do this is one of the ways you can show this is that there's a triangle. Okay. So here's a triangle, and here's the line parallel to it. If this is A, and this is B, then these are parallel, and this is C, then this angle is B, and this angle is C, and this just shows that A plus B plus C is equal to 180. So this means that this sum is equal to 180. And so if you divide both sides by 2, you will get that A plus B is equal to 90. And this angle is A plus B, which is equal to 90. And so that means that this triangle is right. So are there any questions regarding this problem? Okay. Well, does it seem like there are any questions? So let's move on to the next pair of theorems, which is the 30, 60, 90 theorem. So in this one, in a right triangle with an acute angle of 30 degrees, we want to show that the leg opposed to the angle of 30 is half the hypotenuse. So once again, I'll be sharing a OneNote. And yes, you should be able to see the OneNote. So here. So we have a right triangle with an acute angle of 30. So right triangle and 30. And so that would mean that this final angle is 60 because this is 90 degrees, this is 30 degrees, and the final number would have to be 60 degrees in order for the three angles to add up to 180 degrees. It's not true that it's 60 degrees. So what we do next is we can create we can create 60 degrees here and 30 degrees here. We can draw a line such that we split the 90 degrees into a 30 and a 60. So then these two are 60 and 60. So this final angle is also 60 degrees. And so that means that this triangle is an equilateral triangle. And that's because all of the degrees are equal, so all of the sides are equal. Yeah, I think all of you should know what an equilateral triangle is because it's pretty well known. And so after that, then this triangle is isosceles because this angle is 30 and this angle is 30. So that means that these two sides are equal, which means that all in all 4 of these sides are equal. And so that means that 2 of these and this are all equal, which means that, and now if we look at it again, this means that it looks something like this. So what that means is that each of these slashes represents half the length of the hypotenuse, and this shorter leg is equivalent to this half of this length marked by a slash. So this leg is equal to half the length of this hypotenuse. And so now we're done with the 30, 60, 90, so we can move on to the converse. And so before I move on, I think I'll just comment for a second on what a converse is exactly. So if a statement says if A, then B, the converse of the statement would be if B, then A. And proving the converse of a statement is pretty important if you ever want to show an if and only if statement, usually abbreviated as IFF. And that's because it needs to go both ways. So A would imply B and B would imply A. Okay, that's a bit of a side note. So regardless, now we're on to showing the converse of 30, 60, 90. And so what the converse says is that if in a right triangle, the shorter leg is half the hypotenuse, then the angle opposite to the shorter leg has an angle of 30 degrees. So now I'll switch here again. So yeah. So we have a right triangle. And so if this length is s, then this length is 2s. And so we want to show that the angle opposite, we want to show that this angle, so this is a target angle, and I want to show that it's 30. So now what we do is we can just add the median. So this will be, so this 2s turned into s and s, because the median cuts the hypotenuse into 2. Oh, well, it's hypotenuse in this case, but in general, the median cuts the opposite side into 2. So this is a right triangle. So we know that these three are all of equal lengths, and they're all s, which means that it's also equal to this thing. And so now you can see that these three are all of equal sides. So that means that this is another equilateral triangle. So this is 60, 60, and 60. And so this is actually, and after this, you can see that this is 90 and this is 60. So this is 30. Or you can also continue on with the tracing. And this angle is 90 minus 60, which is 30. So this angle, and these two are equal length. So this angle is 30 degrees. And well, either way, you have just shown that it's 30 degrees. So that is how you show this. Okay. And the next up is this one. So we have a 15, 75, 90 right triangle. And what we want to do is show that the altitude from the vertex of the right angle is 1/4 of the hypotenuse. So next up is this question. So first, I'll share a OneNote to explain what's in altitude. So basically, here is a generic triangle, and this is an altitude. Basically, you drop a perpendicular from one vertex to the opposite side, and yeah, that's what an altitude is. And so now you want to show that this is exactly 1/4 the length of a hypotenuse for a 15, 75, 90 right triangle. And by the way, by convention, when talking about right triangles or triangles in general, you can usually just define them as it would be fairly understandable for the famous ones. You can just call them A, B, C, where A, B, C are the angle measurements in increasing order. For example, it would be understandable to call it 30, 60, 90, 15, 75, 90, 18, 72, 90. And well, you can also do stuff like 60, 60, 60, or 45, 45, 90. And people would usually understand, but These two are generally more well known as equilateral and isosceles triangles, obviously. But yeah. Anyways, so now 1575. So it would look something like and here is the altitude. Okay, that's not the best triangle, but please just think of it as a very good right triangle. And so next, make it bigger. Yeah, I'll redraw this. Too much. Okay, this is better. Not by much, but anyway, so this is 15 degrees. So next up, so you can angle trace all you want, but 1/4 is rather hard to come up with in geometry naturally without using any multiplying. So you can see the 1/4 in the problem, and so you can kind of get reminded of the fact that this is, if this is s, this is s over 2. So what you can do is you can add something more like this. Yeah. Okay. I was thinking that this is nowhere close to a 1575/90 triangle, but it's fine. So with the 30/60/90 triangle in mind, where this is s and this is 1/2 s, we can create a 30/60/90. And so the way we do this is by adding a triangle with angles. And so this would have degree 150 because that's 180 minus 30. And so now this is 150 and this is 15. So this would be 15 degrees as well. And that's just because it's 180 minus 15 minus 30. And so this is actually, these two are equal. And also this degree measure is 30 and this degree measure is 75. So this angle is also 75, which means that these two are equal and these two are equal, which just means that these three are all equal. And so that means that this, and so this is the hypotenuse. So I'll refer to it as h. So this length is h over 2. And now this angle is 60 and this is 30. So now what we have here is 60, 30, 90. And this length is h over 2, which means that this length is h over 4. And that's just because of the 30, 60, 90 theorem that we showed before. And so that means that this length is equal to 4. And this is just the altitude that we were trying to show earlier was 1/4 the length of the hypotenuse. So yeah, this is done. Are there any questions? No? Okay. Well, then this is a problem that's left as homework. And so in a triangle ABC, angle C is 45 degrees and angle B is 30 degrees. And so you want to, okay, so what E be the symmetric of B with respect to C means is just you're basically taking segment. So you're basically reflecting B over C. What that means is basically what that basically means is that the result would look something like this: BCE, where these two are equal. So that's what E being the symmetric of B with respect to C. So I can draw a full diagram. So it would look something like this. A, and this is 45, and this is 30. And so you want to find this red angle. So yeah, this is basically the problem that you're trying to do. And these are the conditions you're given. So yeah, that's this lecture's homework problem. And so if you want to take a picture, please do so now. This diagram is probably slightly better to take a picture of than the problem statement, just because it's easier to understand. So yeah, without further ado, so now we can, my lecture is done, and now it's Ethan Hand's turn.